So in this segment, we look a little bit at the quadratic term and also at variance inflation. Again, I'm looking first at what the model thinks is happening with the quadratic term, and then I look at the raw data. And here I'm setting all other x variables to 0 and plot the response variable, the increase in votes for Bush, as a function of the Bush 2000 votes with and without e-vote. And you see that, well, it's a shift. It has to be a shift. The indicator variable shifts the percentage down here a little bit. Whether it's large or not, I don't know. But we see a quadratic trend in here, right? So do we have the quadratic trend in the raw data? Here are the raw data, Bush 2000. And here we have the residual of the linear model. Now keep in mind, the linear model already adjusts for the linear trend of Bush 2000. So the linear trend is if you run a straight line through this, and the residual is just to see whether the straight line should be curved, right? So you don't expect to see the same kind of curve because the linear trend is already out. So you're just trying to see a departure from the linear trend. To see this a little bit better, I have added a smoother in here. It's a lowest smoother. And what this does is it basically looks at the neighboring points and computes an average in a non, well, we don't need to talk about the details, but it sort of helps to guide the eye. Now, with a little bit of, we can sort of see a little bit of a quadratic trend, right? But it would depend pretty much on this observation. Without this observation, we don't see a quadratic trend. This is the smallest observation, which we know is one of the two unusual counties. I forget whether it was Broward or Howard. What was it? Let's see. It's Broward. Broward. So it's all due to Broward County, and without Broward, there wouldn't be any quadratic trend in here. So we may believe it, but it hinges on this one observation. Here is the Stata code for completeness, and I'm now looking at variance inflation factors. The variance inflation factor for the linear model is as follows, and if we look, we have some values that are relatively high. The votes in 2004 and Dole 1996. But basically, this was a reflection of the fact that they tend to vote the same in subsequent elections, right? That's why we have higher variance inflation. So it's not that fantastic. E-voting in here is not correlated with anything. That's good. Hispanics not correlated. That's good. Now here's the same thing for the Hout model, and wow, that's numbers, right? Before we were worried about 10, 11, and 12. Now we are worried about 2000. That's a different order of magnitude of a problem. Now, in part, when you have x and x squared, those are necessarily correlated. You could subtract the mean to decorrelate them a bit, but it comes, if you use functions of the same variable, you're going to have some correlation in there. But it's a bad problem here. So which model in the end is right? I think the original linear model is fine, including Palm Beach and Broward County is fine. So that didn't have any interaction, any quadratic effect. The linear model with the quadratic effect, excluding Palm Beach and Broward County, is also okay-ish. The quadratic effect only depends on Broward County, so I'd probably prefer the original linear model. But either way, both leads to the same substantive conclusions. All right, that's the end of this, and I hope it was exciting. I find it exciting.